Alright, for our next problem we're going to do implicit differentiation. Now implicit differentiation is basically taking the derivative of a function that's not defined explicitly for y. That's why it's called implicit. So anytime you see a y with a squared or a y on both sides of the equation, implicit differentiation is the way to go. Now the way you do it is you take the derivative like you would before, but instead, whenever you take the derivative of a term involving y, you need to include a dy dx. In order to help you think about this, think about it like chain rule, where you're taking the derivative of an outer function, and the derivative of the inner function is dy dx. You need to include that g prime, that derivative of the inside. So, without further ado, we have y squared equals 2x cubed plus 3xy plus 5x. And we're going to take the derivative implicitly. So the derivative of y squared is 2y dy dx. Alright? Now it's 2y dy dx because, as I said, the derivative of the inside function is y, is the derivative of y, dy dx. So now we take the derivative of 2x to the third, and that's just 6x squared. And be very careful here. This is a product rule. The way to think about it is that there's a 3x term, which is a function, and y, which is a function. So the derivative of the first is 3. The second left alone is y, plus the first left alone, 3x, times the derivative of the second, which is dy dx. And then the derivative of 5x is just 5. Now from here, what you have to do is you have to isolate the dy dx. The way you do that is you move it all to one side, and then you move everything that doesn't have a dy dx to the other side. So to do that, I subtract 3x dy dx. So I get 2y dy dx minus 3x dy dx equals 6x squared plus 3y plus 5. Now I'm going to factor out a dy dx. So dy dx times 2y minus 3x equals 6x squared plus 3y plus 5. And then you divide over to get dy dx equals 6x squared plus 3y plus 5. All of that over 2y minus 3x. And that is your first derivative using implicit differentiation.